Welcome back, students, for the next section. We will start with the continuation of previous class. Question number 5. A solid round bar 4 meter long and 5 centimeter diameter was found to extend 4.6 mm under a tensile load of 50 kN. This bar is used as a strut with both the ends hinged. Determine the buckling load for the bar and also the safe load, taking the factor of safety as 4. So compared to the previous questions, in this question the Young's modulus is not given, but indirectly some other parameters are given to find the Young's modulus of the material. So the given condition, the actual length is given as 4 meter, the diameter of the bar is given as 5 centimeter, which means I could calculate the area as 5 by 4 into d square, that is 5 by 4 into 5 square, which I will get it as 625 pi into pi mm square. Now the extension is given as delta L and the tensile load is given as 5000 Newton. So that is given in order to find the value for Young's modulus. That is, in this problem the value for Young's modulus is not given, but it can be calculated from your basics. As you know, Young's modulus is nothing but your stress, that is your stress by strain, that is it can be written as stress by epsilon, right? Stress is nothing but your force divided by area, and Young's epsilon, that is your strain, I can write it as delta L by L. Here this force is given as 5000 Newton and area you have already calculated. Delta L is the change in dimension given and L is the total length of the bar. So all the parameters are provided for you to find the value for Young's modulus, which means I can write this one as this for 50,000 Newton divided by area, that will get it as 625 pi. So that will constitute your stress, that is sigma, the whole divided by delta L, it is given as 4.6 mm divided by the total length of the bar, that is given as 4000. So you are getting the value for your Young's modulus as 2.214 into 10 raised 4 Newton per mm square. So once you got the value for Young's modulus, you can find the value for your crippling load, because it is given the strut is hinged at both the ends, so your actual length will be your effective length itself. So this one I can write it as this is equal to pi square into E we have just obtained, that is 2.214 into 10 raised to 4 into I value, it is a solid circular bar, so that is pi into d raised to 4. D is given as 50 mm, so 50 raised to 4 divided by 64 the whole divided by LE, that is 4000 the whole square. So we can write this one as, this value we get it as 4190 or 4189.99, that is 4190 Newton. So we'll get the value for a crippling load as 4190. Now the safe load I can write it as, that is 4190 divided by the factor of safety, which is given as, the factor of safety is given as 3. So I can write it, this is equal divided by 3, sorry, it's provided as 4, it's given as 4. So the safe load we can get it as 1047.5 Newton. So I hope you understood this. Now the next question and the last question from this topic. Determine the crippling load for an I-section joist 40 cm by 20 cm by 1 cm. Joist means it is a column. Okay, this I-section is used as a column and 5 meter long. It is used as a strut with both the ends fixed. The Young's modulus of the joist of the material is given, a column is given as 2.1 10 raised to 5 Newton per millimeter square. And the given data are you have given the dimension of the section I section as 40 cm by 20 cm by 1 cm, as you can see in the figure. Actual length of the column is given as 5000 mm. The Young's modulus is given as 2.1 10 raised to 5. So we need to find the moment of inertia about both the axes. Since you have already studied this, how to calculate the moment of inertia of a section in your previous semester, I'll just discuss the basic concept. So in order to find Ixx, what I do is I'll consider this whole section. I'll just show you. I'll consider the whole section as a rectangular section, and from that, if I deduct these two small sections, then I'll be getting my moment of inertia. If I draw it here, I have the I section like this. The I section is like this. So I'll consider this as one rectangle. This whole is one rectangle. This is having a size of, this is having a size of, this is given as 20 centimeter, and this is given as 40 centimeter. And from that, if I deduct these two, that is, this is having another two rectangles, these two rectangles, moment of inertia, I will be getting the effective moment of inertia of the rectangular section, right? So if I deduct this one, that is, one is the smaller section here, and the other one is another smaller section here, I will be getting the combined moment of inertia of the whole section. So this one I can write it as, this distance will be what? This distance is actually this distance, right? This one. So up to here it is 20, minus 1 it will be 19, divided by 2. So this will be 9.5 and this will be 9.5. Similarly, along the y direction we have total 40. From that, 1 is deducted here, 1 is deducted here, so the remaining will be 38. So I can write this one as, this will be 9.5 centimeter and this will be 9.5 centimeter, and the total length will be 38 centimeter. This will be 38 centimeter. So this one I can write, this is the x-axis, right? This is x-axis, this is the x-axis. So I can write this one as, this one will be pi, sorry, not pi, this will be b d cube by 12. So here b is 20 into 40 cube divided by 12 minus the other two moment of inertia, that is, we have the moment of inertia about the other axis, that is 9.5 into 38 cube divided by 12 minus 9.5 into 38 cube divided by 12. So we'll get this value as 19786 centimeter raised to 4, or I can write in terms of millimeter raised to 4. It is 19786 into 10 raised to 4 millimeter raised to 4. So this is a value for my Ixx. Similarly, you can find the value for Iyy. So you can see the YY axis is actually coinciding with all the other, or it is coinciding with the center of gravity. So the basic thing I need to do is just divide into different figures as you have studied in your previous semester. So I will consider this as my first figure, the vertical member as my second figure, and this small thing as my third one. That's my third one. So considering these three, I have the first one, moment of inertia of this one I can write it as Iyy1 plus Iyy2 plus Iyy3, because your moment of inertia is coinciding. So this one will be actually this is the first one, that is 20, and here this will be 1 centimeter, 20 centimeter, 1 centimeter. The other one is like this, that is having 1 centimeter thickness, and the total length we can take it as 38 centimeter, and the third one is like this, that is 20 centimeter and 1 centimeter. So the total moment of inertia we could write it as, this will be, the axis is like this, the axis is actually going like this, so the perpendicular distance you could match it based on your understanding for previous semester. That is, I can write it as, for the first case it will be, the lateral dimension is 20, so this will be 1 into 20 cube divided by 12 plus, second case the lateral dimension is 1 centimeter, so that will be 38 into 1 cube divided by 12 plus again 1 into 20 cube divided by 12. So we'll get the value for your moment of inertia as 1336.5 centimeter raised to 4, or I could write this one as 1336.5 into 10 raised to 4 millimeter raised to 4. So that is the value for your moment of inertia. So the least value for moment of inertia you will obtain along the y-axis, that is 1336.5 10 raised to 4 millimeter raised to 4. So in the question it is given the strut, both the ends are fixed. So effective length is L by 2, that is calculated this one as 5000 divided by 2, that will get as 2500 mm. So the crippling load we can calculate by general equation, pi square EI by L square, that is we can write this one as pi square into E. It is given in the question as 2.1 into 10 raised to 5 into I. We have just calculated the least moment of inertia, that is 1336.5 into 10 raised to 4 whole divided by LE, that is 2500 the whole square, and we will get this value as 443280 Newton, or in terms of kilonewton if I write, that will get it as 4432.08 kilonewton. So in this question the only part you need to be careful is how to determine the moment of inertia, which you have already studied in your previous semester. So I hope you understood the problems from this column part. We have 2 assignment questions which will be posted soon. So thank you.